You're welcome back to Join Mathematics. Let's continue from where we stopped. In our last lesson, we saw this graphical representation of a position vector. It's called a position vector because it is relative to the origin. It is relative to the origin O. That is why it's called a position vector. Therefore, we know that the vector OP has a magnitude, or we call it a vector A, has coordinates of x, y. Now, there is a way to represent position vector. Okay, so if we have position vector, or if we have a coordinate of x, y, the position vector is represented as x, y. So the top value represents the value of the x-axis, and the second value represents the coordinates on the y-axis. So if we have another vector in the same order, and now let's call this one OQ, which let's call this x2, y2, and let's call this vector B relative to O. Now we know that vector OQ is equals to B, and it has coordinates of x2, y2. Okay, if the coordinate is x2, y2, then we can say that the position vector is equal to x2, y2. Now we can come to a conclusion that A, which is vector OP, is equal to x, y, and likewise B, which is vector OQ, is equals to x2, y2. Now with this understanding, now we can move on to this graphical representation. We have three vectors, or let's say three line segments, okay, representing position vectors, because they are all from the origin. They are all relative to the origin. So we have line segment OA, we have line segment OB, and we also have line segment OC, line segment OD. Now we are asked to evaluate the position vectors of OA, of OB, of OC, and of OD. Now you can pause the video right away and give it a try. Okay, now OA is of coordinates of 3 on the x-axis and 5 on the y-axis. Now all we are going to do here is simply what we did in the previous slide. When we have coordinates of xy, the position vector is written as xy. When we have a coordinate of x2, y2, the position vector is written as x2, y2. So we have coordinate of OA, which is as coordinate of 3, 5. Therefore the position vector is written as 3 and 5. You can see it's very simple. Now OB has x-axis coordinates on the x-axis to be 4, and on the y-axis is given as what? -5. So we can, okay, let's change this. So we can say that OB has a position vector of 4, -5. Moving on, let's go on to OC. OC has a coordinate -2 on the y-axis, -6 on the x-axis. So the coordinate of OC, we can write it as -6, -2. So the position vector therefore will be -6, -2. Alright, I'm sure you have tried for OD. If not, pause the video and give it a try. Now for OD, we can see that the x-axis is -5 and the y-axis represented by 4. So we have -5 and then we have 4. Therefore, the vector OD, okay, is written to give us -5 and 4. Now, in our next lesson, we will have exercise to ensure that we understand this particular theorem.